Welcome to 4B, which is determining the number and type of solutions of a quadratic using the discriminant and the graph. So two different ways. First thing we need to figure out is just how many solutions does a function have? So one way you can tell is by the equation, the function. And it's really looking at the exponent. Biggest exponent will tell you, biggest exponent of a function will tell you how many solutions it has. Will tell you how many solutions the function has, or the equation. So in this case, there are two solutions. Now we need to know what type of solutions they are. They can be real, they could be, or they could be imaginary or complex. So there are two different ways you can tell how many solutions and what type they are. One is by looking at the equation. That's just telling you how many there are. But then to tell what type, we can look at the x-intercept. So how many times it crosses, how the graph crosses the x. X-axis. And then also the discriminant. Now this is a new word. The discriminant, you should have at some point heard about the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. That's the quadratic formula. But within this, you don't actually have to use the whole formula every single time to determine what type of solutions they and how many solutions a quadratic has. It's actually inside, underneath the radical. This is called the discriminant. So that is the discriminant, is the b squared minus 4ac. That's what we're going to use. So the b squared minus 4ac. And from that, we can tell what type of solutions. If b squared minus 4ac is a positive number, if it comes out to be positive, then there are two real solutions. If it is a negative number, then there are two complex solutions. And if it is, the number is 0, then it is one real solution. But it is also, but it's a double, call it a double, that whatever number or whatever the solution is, it's double. There are two of those, and we'll get to that later on. All right, so look in example 1, find how many solutions and what type of from the following graph. So we're looking here, when you're looking at graphs, we're really primarily just focused on the x-axis. That's all you're looking at. Look at the x-axis. How many times does it cross the x-axis? Well, the first one doesn't cross or touch the x-axis at all. So it says 0 real solutions, but this tells us, so 0 real solutions because it didn't cross the x-axis. But it also tells us then we have, it is a quadratic. It is two slopes. That's another way you can tell is two different slopes on the graph. So 2 slopes means it's 2 solutions, and so 2 of them are going to be complex. And that's really ultimately on a graph like this what you need to write. So 2 complex solutions. On the second one, we're looking at the x-axis. Where does the graph intercept the x-axis? Well, right here, these 2. So there are 2, those are real solutions. They're at -2 and 5. Those are real numbers, not imaginary numbers. So 2 real solutions, and there'd be 0 complex, because all, and again, it's a quadratic. There's 1 slope, 2, so it's a quadratic. Or you could look at the shape of the graph. The third one here has 2 solutions. It's quadratic. but we're looking, it only touches the x-axis once. This is called a one real solution. And anytime the graph, as it's approaching the x-axis, hits it and bounces off, it turns, and the minimum or maximum point is on the graph, this would be called a double solution. And if you're looking, another way to look at it is right around the x-axis. It is, if you look at right around the x-axis, just kind of general shape of the graph around the x-axis is a quadratic. Quadratic, think two solutions. So this is a double solution. So there are two solutions. And there's your, so you say one real solution and it's actually a double. And that's it for graphs. So now let's get to calculating from the discriminant. So now we're not graphing. So here we have to know, so this is all about, remember the discriminant is b squared minus 4ac. So we're going to need to know what a, b, and c are. So in number one, the a is always in front of the x squared term, so that's a, 1. B is always in front of the x term, and c is always the constant, the number by itself. So we do the b squared, so it's, I always put it in parentheses, b squared minus 4 times a times c. And let's simplify this down. So we have 2 squared is 4. 4 times 1 times 3 is 12. 4 minus 12 is negative 8. When you get a negative number, this means two complex solutions, meaning there's an imaginary part and a real part. So two complex solutions. Next. So here we have a is, no, that is not a. A is negative 1, b is 3, and c is positive 10. So you have b squared minus 4 times a times c. Almost just wrote a c. We do 3 squared is 9. Negative 4 times negative 1 is positive 4 times 10 is 40. 49. 49 is a positive number. That means there would be two real solutions here for this graph, or this equation would have two real solutions. So we know the type. All right, the last one. This one's a little tricky. You notice the first two have, they're already in y equals, 0 equals. They're in standard form. The last one's not. This negative 9's here. We either need y equals or 0 equals or f of x equals. Well, that negative 9, we can move it. Move it to the right side so we get all of the terms on one side. Make the equation equal 0. That's in standard form. Once it's in standard form, then we can actually tell what, and just reminder, standard form is ax squared plus bx plus c, and it equals 0. It doesn't matter if it's on the right side or left side. And this, so you can always switch those around. Equation means equal sides. So we have a is 1, b is negative 6, and c is positive 9. So we have b squared, negative 6 squared, put it in parentheses if you're putting it in the calculator especially. Anything squared is positive, so negative 6 squared is 36. Negative 4 times negative 1 times 9 is negative 36. 36 minus 36 is 0. This means we have one real solution, but because the biggest exponent is a 2, there are two solutions. Well, we can't just have one real solution. It's just one that's going to touch the graph, so this is a double solution. So I would write that as a double solution. And if you look, if you were to go to Desmos and graph each one of these, for example 2, they actually are the graphs. So these graphs here are these equations. So that would, you'd be able to line it up with that. So we'd be able to tell visually and then mathematically from example 1, example 2. Hopefully this helps.